Hey guys, and here we go with the very final video for Chapter 1, Section 3. We're just going to do a couple of quick example problems, and they're all going to revolve around one central, very important real-world situation, which is the concerns of clowns. Now, here we have Babyface the Town Clown, and I've got bad news for you people. He's not happy with what's going on, because it turns out that the number of clowns hired to perform at children's birthday parties completely changes based on how much money these clowns charge. So if the clowns don't charge any money, then you can imagine that someone who offers to show up at your kid's birthday party dressed up weirdly for no pay at all is not going to be looked on favorably. And then if they charge more money, they get hired more often because they're more respectable. But then if they charge even more than that, they don't get hired as much because they're too expensive, and so forth. And so here's what we're looking at. My X values are going to be how much money is charged for creepy birthday clowns, and my Y values are going to be the number of creepy birthday clowns hired for a birthday party. So remember, f of x and y basically mean the same thing. And we've got a handy dandy little graph plus a table of values along the graph. So on the graph, you can generally see the shape of how things roll, and the table gives you the specific values we'll be using for the first couple of problems. All right, so that's looking pretty good. So the first problem we're going to be looking at is this. We're going to find the interval with the greatest average rate of change. So maybe Babyface the Town Clown is thinking to himself he wants to hit that sweet spot where if he charges any more money or any less money, he's not going to get hired quite as often. And he can do this by figuring out on the left and the right-hand side of a certain price if the change is positive or negative or what. So he's going to start playing around with these average rates of change. And so what we're going to do is go up to this table and look at every single different possible interval and find the greatest average rate of change. Well, we're not going to look at every single possible interval because there's a lot. We could go from 10 to 20 or 10 to 30 or 10 to 40 or 20 to 40 or whatever. But what I'm going to do is I'm going to work the two most obvious intervals and then show you which one of those is right. Now remember, average rate of change means the same thing as the slope of the line that connects 2 points. And this isn't something you need to know right now, but it's a good intuition to have. And so for example, you can look at some of these points on the graph, like let's say we got a point there, and we got a point there. And there's a line connecting them, and that line has a certain slope. Or there's a point here, and there's a point here. There's a line connecting those suckers, and that's got a certain slope, and that slope's even higher. And in fact, we can even do better in the first case. Let's look at the line joining the first point and that second point there. And that point's just a little bit higher. So, you don't need to think about all of these precisely, but it gives you a good tip. What we're going to do, because of this, is we're going to look at the average rate of change between those 2 points, and then we're also going to look at the average rate of change between those 2 points. And those are the biggest two that we're going to get, and it turns out that one of those two is going to be bigger than the other. So if you wanted to answer this question completely on your own, you would have to go through and calculate the average rates of change for all of those pairs, and that would kind of be a pain. But we're only going to do two, and that's going to be pretty easy. So let's do the first ones, and that's the x value 10 and the y value 30. Let's write these points down, 10, 30. And it goes all the way to 20, 70. That's the first average rate of change we're going to compute, and then average rate of change is y2 minus y1 over x2 minus x1. Simplifies down to 40 over 10, which is 4. 4 clowns per dollar. That's pretty cool, I guess. All right. And now let's do the other interval we looked at, 4080 to 5160. So we're looking at 40, 80 to 50, 160. And we get average rate of change equals, same deal, y2 minus y1 over x2 minus x1. And let's scooch off to the right a little bit here. This ends up being 80 over 10, which is 8. And 8 is totally bigger than 4, so this is the guy that we like. This is the interval with the biggest average rate of change. And actually, I shouldn't be drawing arrows to that. That is the biggest average rate of change. But the interval with the biggest average rate of change, that was the question. Find the interval. The interval that we're looking at is this guy right here, or more specifically, from x equals 40 to x equals 50. When they ask you for the interval, you can write it like this, or you can write it in interval notation, but basically all they want is just the x values. So for exercise 1, this is the answer we're looking for, x equals 40 to x equals 50. All right, now we're going to move on to exercise 2. I'm going to draw a little squiggly line there to separate things out. What we just found was the interval with the greatest average rate of change, but exercise 2 is asking us the other sort of change that we talked about, the interval with the greatest relative change. And so remember, we've got a different formula for relative change. Relative change is y2 minus y1 over y1. So we can just look at the exact same two intervals. Let's go back up here. So actually, we can just even go right here. Look, I've written them down in multiple places, people. Ha, I'm so useful. Okay, so the points that we're looking at are going to be 1030 to 2070 versus 4080 to 5160. And just looking at these numbers, just like with the average rate of change, these guys are a lot bigger. And so it kind of intuitively seems like those are going to be the biggest relative rate of change again, but actually it's not true. The first one's going to be bigger. So check it out. Here's what we get. Relative rate of change for the first pair is going to be y2 minus y1 over y1, and that's 40 over 30, which is 4/3. And 4/3 is approximately 1.33. Now separately, if we look at the 4080 versus 5160, we get 160 minus 80, because that's y2 minus y1, all over y1. This is 80 over 80, and that's just equal to plain boring old 1, not quite as big as 1.33. So for this side, the largest where am I? Oh yeah, okay, the largest relative rate of change is 1.33, but we're asked to find the interval, and so the interval here is from x equals 10 to x equals 20. That's the correct answer for the interval for the largest rate of change. Largest relative change. And so this illustrates the fact that the largest average rate of change and the largest relative change can happen in different places. They're different concepts. All right, let's move on to exercise 3. We're asked to find all the intervals where f of x is increasing. So this is going to be fun. We get to scroll all the way back up and look at this function thingy again. Oh, and those lines are in the way. Let me get rid of those. Bloop, 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 bloop. All right. All the blooping is done. So we're going to find the intervals where, wait, I don't even remember what we were doing. Intervals where f of x is increasing. That's right. So that means just where the y values are going up. And let's mark these guys in blue. So to me, it looks like f of x is increasing from right here all the way through right there. Let's go ahead and call that x equals 10 to x equals 30, roughly speaking. And we can do this if we want to. So there's a place where it's increasing. Now from 30 to, let's say right around 40, oh, that's not right. It's really like, right, it's like 42. From 30 to 42, it's decreasing, but then from 42 on, it starts increasing again. And we'll just go to 50 because that's the only place that the table goes to. So it looks like we're increasing from 10 to 30, and then from 42 to 50. X equals 10 to x equals 30, x equals 42 to x equals 50. And those are just the places where the y values are going up. So that's cool. That's not too much of a headache. And the very last exercise, and I bet you can see this coming, it's about concavity, and we're asked to find all the intervals where the original function is concave down. And this is the thing that people can have a harder time with. We want to find out where it's curving down rather than curving up. So let's go back up here. Let's get rid of all this blue nonsense. Bloop, 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 derp, 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 derp. All right, now let's do some red to indicate concave down. And remember, concave down means that it's actually curving downwards. So it's obviously curving downwards right around there. But the question is, how far does that downward curve go? And to my eye, it looks like it goes down here, but then stops right around at this point. And then on this side, looks like it goes a little farther down there, but stops right about at that point. So it's not a fine science, but you really do want to identify the points where it's obviously curved in a downward direction as opposed to an upwards direction. And so you can have a little bit of a wiggle room, but in the end, your answer should look very close to mine, even if not exactly like it. And so it looks like these points that we figured out are something like, x equals 17 to x equals 36. And again, if you're doing a problem like this on a test, if you say 16 to 35, no one's going to really care, as long as you get the right idea. So for this answer, we're going to say from x equals 17 to x equals 36. And that's it, people. Mission accomplished. I'll see you next time.